Very good morning. So today's class we will be discussing the inductive bias, right? So far we have discussed what do you mean by concept learning, how to through the concept learning, how to create a target function, or how to create the how to identify the possible instances and what are the possible hypotheses. So that is what we have seen so far in the class. So now today's class we will see the what is a inductive bias, what is the purpose of inductive bias. So before jumping into that inductive bias, purpose of inductive bias, we will see what is the remarks on candidate elimination algorithm and version space algorithms, right? So there are certain questions are not answered in the candidate elimination and version space and finders algorithm. Whereas finders algorithm, it tells you it may not be suitable for the negative test cases, only it is suitable for the positive test cases, not test cases, text examples, right? But whereas your candidate elimination algorithm takes care of both positive hypothesis and the negative hypothesis, but still it is not suitable for the uh, certain hypothesis. It is very difficult to check for all the hypotheses in the candidate elimination algorithm, right? So the from the main set, then the generated set in between whatever the intermediate sets are there, that is what we used to call the version space, right? So I quoted with other examples like iPhone, right? Previous days, older days, there are only the concept, only the set was there. Nowadays there is a version space for every product, every item, every hypothesis. There are different versions are they started coming. Even you take iPhone as a concept, then 5s, 6s, 8s, 11s, 11 plus something. There are different. In the same hypothesis, there are different versions are started coming. So nowadays the version space is one of the main concept, focusing concept, right? So now from the candidate elimination algorithm and version space, there are few questions are not answered. One is, will the candidate elimination algorithm gives us the correct hypothesis or not? What is the purpose of doing all these things? We want to identify or we want to fetch the best fit hypothesis. That is what our agenda from starting from your finders to list elimination, again this candidate elimination algorithm, etc. Right? But still the questions are not answered. It is very difficult to get the best hypothesis, best fit hypothesis. Now, the second question is, what training example should the learner request next? So that we may not know. So that is also one of the biggest challenge in this CE and version space. What is the next training algorithm, next training example, so that we may not know. So that is completely depends on the previous state. So that is one of the question. So in order to solve these two issues, we are moving on to the inductive bias. Inductive bias is one of these subset of the hypothesis. We are making some set of assumptions on restricted conditions. That is what your inductive bias is all about. Instead of checking the entire samples in the set, we will take only few set of examples and we will do the training model. For example, uh, instead of telling I want to go to I want to eat outside, something like that. That is the concept. I want to eat today. I want to have dinner outside. But that is a generalized hypothesis. For example, I want to eat only biryani is outside with the Coke and 7 Up, thumbs up, then we are making some restriction on the hypothesis. We are making some restriction on the input samples. So then such cases we will say inductive bias. So that is what this inductive bias is all about. Always it will come with the set of constraints, set of restrictions, set of assumptions. That is what your inductive bias is all about. So now if you define inductive bias of is also we used to call kind of a learning algorithm, right? So inductive bias also sometimes we call it as a learning algorithm or learning bias. So learning bias, this bias says it is a set of assumptions that the learner uses to predict outputs of a given inputs that is has not encountered. So meaning, so this we can say inductive bias is one of the set of assumptions or set of constraints that learner use to predict the output. So this prediction is nothing but so our main objective is generally a prediction. All your active learning, your machine learning, your concept learning, all these learning says about only a prediction. We want to something to predict, we want to something to learn, we want to something to train. So that is what this inductive bias is all about. What is inductive bias? So generally in a simpler way we can make inductive bias always needs to make some assumptions. Experience alone does not allow us to make conclusions about unseen data instance. Yes, that is one of the very important point here. We cannot make a conclusion by the experience. So that is not alone sufficient. So you need some kind of conditions, assumptions or restrictions in order to identify the best hypothesis. So this IB is used to find the best hypothesis. That is the purpose of this inductive bias, right? There are two types of bias. One is your restriction bias, another one is the preference based bias. So restriction based bias always limits the hypothesis space. That is what I said the first one. It never go with all the samples. It will go with only few samples. For example, I have 50 data sets. Out of 50, I will go with only random samples or two positive, two negative, one is some null values. So it will go with like this. Preference sample. So restriction, we can say it is from the example, right? That is the mark. Yeah. So this is, we can say from the example. This is from, we can say from the experience. From the experience, we will derive the rules. So derive the rules. Preference, impose the ordering on hypothesis space. So this is one is from example, another one is we will go by experience. So in simpler way, I can say from the, for example, I want you to predict something whether rain will come or not tomorrow. From the past data, you can say that is the restriction. Preference, I can say I can call some weather person, weather prediction person, weather forecasting person, or some the person who is expert in that domain can be called and he may do the analysis. He may do the assessment. So that is what the preference based. We call the specialized version. That is what experience. We will derive the rules from the experience is called a preference. We derive from the example is called restriction. So from the past analysis and the experience, we can we know that there are three parameters. One is hypothesis space, active learning, machine learning, and concept learning. So we know what is a hypothesis space. Hypothesis space is nothing but set of all legal hypotheses, right? So we use, that is what we used to call, this is hypothesis space. This is only a legal hypothesis. Then here you can say this is a concept space. I have a set of all legal hypotheses. These are legal hypothesis. From this legal hypothesis, I am taking a few set of examples. So this is few training samples. I am restricting from this overall concept space. I am taking only few set of samples for the my training. So that is called that is the few samples we used to call target concept, right? So now this restriction is we used to call inductive bias. This entire thing we used to call hypothesis space. We are doing all these things under the hypothesis space. So this is what your inductive bias, I think you can able to understand now. So what is this the three types of learning? So these are all comes under the concept learning, right? Before that, even your machine learning, first we started with active learning, then your machine learning, then concept learning kind of. So what is a machine learning? Machine learning is always says even either supervised or unsupervised, but it all the methods is allows you to predict something to obtain some level of accuracy, right? So that is what machine learning is all about. Then what is active learning? Active learning is all about you have a set of huge space, but you are interested only in some learning subset of space. So that is what your active learning. So generally we will do reduction in this such space is active learning. Concept learning is all about we are finding a best model from the set of hypothesis. That is what your concept learning is all about, right? So there are some more terminologies as you know already. Examples generally we use to represent with x comma y. So this the instance x with the label y, right? So when you say x comma y is nothing but x is an instance, then with the label y. There are other one training data. You know, training data is nothing but collection of examples which is observed from your learning algorithm, right? So learning algorithm. So this we can say this is collection of examples. Whereas instance space is nothing but set of possible instances which is describable by the features. So these instances are always described by the features like your example, your sunny, your like your sky, your temperature, your warm, cold, weather, something like that. So that will be defined by the temperature features, whether warm or cold, whether strong or normal, whether it is a cold or normal, something. So that can be described by the feature. That is what is possible instances. Concept is nothing but subset of objects from the X. So that is your concept. Target function, we are mapping each instance to the target label. That is what your target function is all about, right? So as we know, this is simple example. So that is a concept learning. This is how we will make the instances. So when I say concept learning, you take iPhone as a concept. Okay. You take iPhone as a concept. When you say iPhone, there are different version spaces are there. So, sorry, you take just a phone as example. When you say phone, there are tablets, there are smartphones are available. Now these here, when you say features is nothing but binary values. We are making assumption only for the binary values. Now when I say phone, I have different features: size, color, screen type, and shape. There are 4 features. For each feature, I have the different instances. When I say size, small and large. When I say color, gray and black. When I say screen type, flat and fold. When I say shape, square and rectangle. So now I want to create my own concept. How do you make a one concept? So now concept is nothing but, so you need a concept for if you need a concept, then you need set of instances, right? So now so this size is small comma large. So I'm making this as my x1. So this is my x2. This is my x3. This is my x4. So I'm making all my assumptions into different parameters. Now my concept is nothing but x1 comma x2 comma x3 comma x4. This is my concept. So now these concepts should be mapped with my attributes. So now tablet and smartphone. So then the features which are belongs to tablet is nothing but tablet is equal to, so large or black or flat or square. So meaning I am taking these 4 parameters. I am taking large comma black comma again flat comma and square. I am taking these 2 for a tablet. Remaining 2 for remaining 4 for the smartphones. Now, so this you can make the different possible instances. Nothing but possible instances. Nothing but formula is 2 power d. So 2 power n. So n is nothing but 4 here. So the possible instances, what are the number of possible instances? 2 power 4. So 2 power 4 is nothing but 16. So 16 possible instances can be possible with these four combinations. You can make small gray fold rectangle, small gray flat square, small gray flat rectangle. So you can make like this, totally 16 possible. But then what are the possible concept is possible concepts are meaning what are the possibilities for different concepts. So then that is nothing but 2 power n. So this is the your possibility concepts. So then that is what this one is all about, 2 power 16. 2 power 16 is your possible concepts, right? So now, so in this case, it is very difficult to go with such many concepts. Suppose assume I'm adding one more parameters here, extra parameter here. So let's see, I'll show you. Suppose instead of flat folded, I am just adding curve. So then 2, 2, 3, then 2. So now the values are changed. Or some more, I am adding some other size, screen type, shape. Then I can add something like what can be done? Camera. So then I am adding front camera, back camera, then rear camera, something like that. So three parameters. So now 2 comma 2 comma 3. So totally you will get 96 instances. Then target concept is 2 power 96. So it is very difficult to 2 power 10 is 1024. Then think about 2096. It is very high. So it is very difficult to evaluate such target concept in real time. So that is why we are moving on to the inductive biasing mechanisms. So that is what this inductive bias is all about, right? So the hypothesis size become huge. So it is very difficult to calculate 2 power 96 hypothesis. So that is what we are doing. We are always taking from the samples, we are taking only some few restricted samples. So this is what few restricted samples, few restricted what do you call hypothesis. So one for yes, one for no, two for question mark. So we are checking this type of algorithms. So that is what your inductive bias is all about. Next one technique is a decision tree in learning. In general decision tree, we are not moving into too much depth about the problems, etc. Just I am teaching you what is a decision tree. In later we will see implementation and everything. So what is a decision tree in learning? So what is a decision tree in learning? So decision tree is one of the powerful learning algorithm in supervised learning, right? So when you say machine learning, it has three types. One is supervised, unsupervised, and your reinforcement learning. So decision tree will comes under the supervised learning, right? We always go with the labels, right? Here learning is happening with the help of labels. So now decision tree induction is a simple and powerful learning paradigm, right? In this method, set of training examples are broken into see the training examples are broken into smaller and smaller subsets, while at the same time associate decision tree gets incrementally developed. So meaning, so you can start with one tree so that such can be developed incrementally, right? So that is what we are dividing set of training example into smaller subsets. So decision tree can be taught as the set of sentences written in proportional logic. So generally we used to call disjunctive of conjunction formal forms. So for example, P and Q and R, this is disjunction. So when I make disjunction of conjunction, I am making again W, Q. So suppose this is how your disjunctive normal forms written in, this is proportional logic, right? So this is what your decision tree, how to represent the decision tree. Some of the characteristics of decision trees are, this is follows the attribute value pairs. Also then discrete target function. So discrete target function, always it will go with the yes or no type, right? Your supervised learning algorithm is always discrete by default. Your unsupervised is continuous by default, right? Then disjunctive description. Disjunctive description is nothing but of your target functions. That is what this one. Disjunctive of conjunctive for normal forms. That is what your target function. This is what your target function T. Also, this decision tree work well with the missing or erroneous training data. So these are some characteristics of decision learning. I repeat, decision trees first characteristics is it will always go with the attribute and value pair. For example, if I say sky, what is the sky? Whether sunny or cloudy or rainy, right? So that is what attribute and value. Also, it is by default, it is a discrete target. It follows the discrete target function. Also, it will go with the distinctive description of the target function. Also, it will work well with the missing and erroneous data. Now, this is how the representation of your decision tree learning for playing a tennis. So the outlook, the hypothesis is nothing but your outlook. Overall hypothesis is nothing but your outlook. This outlook is divided into three categories for playing a tennis: sunny and rainy, or any other hot. You can say something like something. You can give any other parameter, overcasting. So we have taken three attributes: sunny, overcast, and rain. Now the sunny is divided into sunny is under the humidity. So sunny is one of the parameter. Then this is the humidity. Humidity has a two, again it is a two training divisions. One is the high humidity and normal humidity. If the humidity is very normal, then he will go for playing a tennis. If the humidity is very high, then no one will go for playing a tennis. So now you can write here the hypothesis. Generally you can write sunny, and if it is a normal, then he will go for play. Yes, we can say yes. For example, sunny and no, then he cannot go, then he never play for tennis. No. So this is how we are writing, this is how we are predicting. So same how the decision tree, how this proportional logic is applied, right? So then, so yes, these all the leaf nodes are your decisions. All these leaves are decisions. All the leaf nodes are your decisions. From the decision you can predict. Okay. So this is your decision learning. There are, assume there are 15 instances are given. Your 15 instances. Sorry, 15 or 14. So 14 instances. 14 instances are given. Now here, see this is your target concepts also given. See, yes, 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 yes. 3, 6, 9, yes. Then 5, no. So totally 14. Target functions are given. So now this decision tree can be represented with the disjunction of conjunction of constraint. That is what I said. This is disjunction of conjunctions. So this is, you can say, that is what this is: sunny versus warm, again versus cold something, again conjunction, again rainy versus cold versus same. So this is your conjunction. This is your disjunction, right? Each path from the tree to root to leaf corresponds to the conjunction of the attribute set. The tree itself, it is a disjunction of these conjunctions. Again, each node represents a feature and each link represents the decision. So these are all the decisions. So these links are decisions. These are your feature. So each leaf node represents the outcome. So that what I said, this is outcomes, final outcome. So now these can be represented with like this. See, outlook is equal to sunny and this generally we used to call and, right? So and humidity is equal to normal. Outlook is equal to straight away forecast. Then outlook is equal to rainy. And if it is a wind, then it will be a week. So this is the third one, this parameter. So all the three parameters were represented here. So this is how your decision tree is all about. So next class I'll teach you how to build a decision tree with the information gain and the entropy mechanism. Okay. So this one is uh, yeah, nothing. That's all. So thank you. So we will meet you in the next class.